Hello everybody, how is it going? This is the heat transfer spring semester class in the year 2020. And my name is Jong Lee, Professor Jong Lee at the School of Mechanical Engineering. And my background is actually not heat transfer, but semiconductor processing. So I use this kind of wafer and create very small, tiny devices. They can do a lot of magical things. Very small devices, very small devices. Well then, a lot of phenomena that we use actually originates from physics, leading to mechanical engineering. And especially heat transfer is a very, very important principle that works behind my little teeny tiny devices. That justifies that I need to learn and teach this heat transfer class. You'll find out that it's a really interesting topic, and it is really important topic throughout the whole engineering life of all of you. And learning all this knowledge will be a really exciting journey into this real nice world. Well, I need to introduce first of all the textbook. Textbook is in Kroll-Perel's Principle of Heat and Mass Transfer. And one of the co-authors, Adrienne Lavin, she is a really famous professor at UCLA. And I did my PhD at UCLA. When I was doing my PhD there, Professor Lavin was really well-known, hardworking, and genius professor in this field. So it's my honor to be able to teach through this real nice textbook. So every one of you should prepare this textbook in English. This is English course, no Koreans, okay? You have to buy English textbook, speak in English, send me an email in English, and submit your homeworks, submit your midterm and finals in English. Okay? So I have already uploaded the syllabus of this course this morning, and I think I can just explain this syllabus and finish up lecture today. And so lecture today is mostly to check out the online connectivity, because most of my lecture this semester will be going through the online lecture. Okay, so let's go through this syllabus together with me. Please open up your syllabus from your ETL or your school website. Okay, check it out. This class number M2794-02600-002. It's a heat transfer course at the School of Mechanical Engineering, Seoul National University, for the spring semester in 2020. Okay, this class time will be on Tuesday and Thursday, starting from 9:30, ending at 10:45 in the cyberspace. Exciting, isn't it? Right? Not in the lecture room, but in the cyberspace. We'll try a lot of fun things that is unique to the cyberspace. This is really nice opportunity to test a lot of fun things. Office hour, even though office hour is in the cyberspace, and Wednesday from 9 to 10. This really means that you can have a web chatting with me Probably I will use a KakaoTalk, maybe something else, but we'll try, we'll see. Lecturer, my name is Professor Jung-Won Lee, and I'm pretty well known in my own field. You can check it out on the website, and I got my own business as well. So my office is actually not in the engineering building, but in the research park. You know, there's a rear gate, and as soon as you exit the rear gate, on your right hand side, there's the IVIT, International Vaccine Institute or something. And right next to it, we have a Seoul National University Research Park, and room 115 is my office. Here's my phone number, 02876-1250. And my email address as well. Please send me email, you know. In any case, you have some questions, you have some suggestions, you wanna meet me in person? Yes, I can have a meeting time with you as well. And the TA, Gi-Gyu Kim, is right here. Okay, can you see that? And is Gi-Gyu there? Please do the chatting, kato with me. Yes. So this class is actually the first class. I'm checking out the connectivity. I would like to see each and every one of you actually is present on the cyberspace. So would you guys please send a KakaoTalk message to the designated site so that I can check out your presence. Okay. Again, the textbook is incorporates Principle of Heat and Mass Transfer, Wiley, 2017. Let me read through the goal of this class, okay? Let me read through it, okay? This class teaches the fundamental phenomena of heat transfer, including conduction, convection, radiation, and material transfer for the understanding of basic principles and applications. Well, the mode of heat transfer, there are three modes of heat transfer: conduction heat transfer, convection heat transfer, and the radiation heat transfer. And you're gonna learn all these three things. And each and every one of these transfer mode has their unique physics and their equation that explains the unique physics. So I remember I saw Professor Rabin, wear these t-shirts with the equations, conduction equation, convection equation, and radiation equation. Wouldn't that be fun? It'll be really interesting and well-established understanding of this unique physical phenomenon. Students will learn how empirical observations and theoretical understandings are correlated with each other, leading to mathematical models. So you will set up mathematical models and solutions. You solve these mathematical models via analytical and numerical methods. Both methods. Wouldn't that be fun, right? Arriving at the reasonable explanations for the physical phenomena. This is very important. We are not just interested in setting up the model. We are not just interested in solving these problems based on these models. We are interested in giving explanations to the physics. That's the final goal, okay? We are interested in understanding what's going on in the real world related with this heat transfer, okay? So really important goal is that throughout this whole process, students will develop advanced inference skills that perceive key process of physical interactions. Okay? This is really important. You have to understand the physics, you have to understand, and you have to be able to explain why such phenomena happens. So modeling and mathematical tools, they're just the tools, okay? The real important thing you need to learn throughout this process is the understanding of physics. Okay, so we're gonna learn all these things throughout the whole course. Based on these analytical foundations, students will culture their abilities to apply the knowledge of heat transfer to the real engineering problems and suggest creative design solutions. Yes, you want to suggest creative solutions. But how? By learning engineering principles. But how? By being able to perceive the real physics, being able to extract out what the real physics means to the real world applications. Then you can become creative. Then you can come up with a lot of interesting engineering solutions. You can come up with these little tiny devices that can do a lot of magical things. I'm gonna explain what this little device can do later on, how they are related with heat transfer, how heat transfer plays the key roles in terms of making these devices function like magic. Okay? So these are the lecture schedules. Okay, let's take a look at one by one. And first week, we'll think about why heat transfer is important, why we are learning this heat transfer. And the second week, we'll start the exciting topic of conduction heat transfer. Explanations, heat conductions in physics. Okay. Third week, simple but exciting engineering applications. It's gonna be fun to be able to learn all these things. Fourth week, analysis of more complicated heat conductions. Will become more and more specialized. Fifth week, time-varying heat conductions. Heat conduction occurs as time changes, and that actually trigger very important intertwined understanding of this time, space, functions. In other words, we're gonna arrive at the partial differential equations, and you should be able to solve these partial differential equations. We all learn these partial differential equations in engineering mathematics 2. Remember that? Okay. And sixth week, we're gonna apply this principle to complicated but interesting engineering applications. It'll be nice, right? Seventh week, so we're gonna switch the gear, shift the gear, and then move on to the convection. How the convection contributes to the heat transfer. What is conduction? What is convection? We're gonna start learning from next lecture. I'm not gonna explain the details now. Eighth week, understanding of convection with fluid mechanics knowledge. You guys learn fluid mechanics, right? How is that fluid mechanics related with this heat transfer? That'll be a really interesting topic, to learn. Ninth week, convection via surface flow. The water flows on the surface, how they take the heat, with this, flow. We're gonna learn all these things. 10th week, when conduction and convection occur at the same time. This heat transfer and fluid phenomena all mixed together. This will create very unique and interesting, exciting topic of understanding this heat transfer. 11th week, convection. Sorry, I just put in convention. Sorry, it should be convection. Convection, not the convention. Okay, so you guys can correct the error. Convection in pipes. You have a pipe, the water flowing in, how the heat can be transferred through this convection. 12th week, interesting natural convection. You have some matter that is hot, and because of the heat, air will flow around this hot matter, and that will create a very interesting, beautiful phenomena, of convection, natural convection. All right. 13th week will change to the topic of radiation heat transfer. How this earth is getting energy from the sun, radiation. How you guys feel warm when you look at the sun, when you actually go outside and face the sun, you feel the heat of the sun by the radiation. Why do you guys feel warm when you go into the bathroom and then turn on the light? Because of the radiation. Radiation plays a lot of key roles in terms of heat transfer. Okay? And 14th week, radiation between surfaces. 15th week. Well, 15th and 16th week, this is really interesting and different, unique topic I can serve to all of you guys. Well, heat transfer is not just about transfer of heat energy. It's also about the diffusion of matter. Diffusion of matter resembles the heat transfer in pretty much every aspect. So you can use exactly same equation to describe how this matter will diffuse. For example, coronavirus will diffuse into the air by convection, okay? And the diffusion process. You should be able to explain how quickly these particles will diffuse based on the understanding of heat transfer. So this is a very interesting topic. 16th week, even more interesting. We're gonna learn how the material transfer knowledge can be applied to bioengineering. For example, you have a diagnostics kit. You have to understand how these little molecules can transfer and diffuse and convect inside a little microchannel, arriving at your target molecule, how they bind, and how can you use such knowledge for the understanding of the best diagnostics kit in the world. So this will be a very interesting chance to extend your knowledge out of this common engineering area. So let me move on to the final topic, grading. You guys are all interested in grading. If you are interested in grading, you have to read the textbook ahead of class. So that corresponds to preview. I'll think about how we can actually give you the quiz problems in the previous section. Basically, before the beginning of the class, we'll go through your preview experience. Starting from next lecture, we'll see how we can do that. And there will be homeworks, of course. You after class, I'll give you homework. You have to solve and you have to submit through online. And one midterm, there will be one midterm, and there will be one final. All these three area will contribute to your grading by 1/3 and 1/3 and 1/3 contributions each. Okay. I think I presented pretty much everything for today, and I hope you guys come back for the next lecture on Thursday. We're gonna start understanding why heat transfer is needed, what kind of examples are there. Probably I'll talk about very simple and easy to understand problems. Maybe I can choose one of the examples from your daily lives, and we will see why physical understanding is important, and we'll actually start from there. Okay, is there any question? I can wait for maybe another 5 minutes or something like that. You can send me a KakaoTalk message, and we can exchange everything together. Thank you very much. Have a good day. Stay healthy. Wash your hands, okay? Thank you. Bye.